Season 5, Motion and Forces, Episode 105, Resultant Forces. Welcome, strangers. Forces, yep. All the forces are measured in newtons. You can measure weight and some other forces with a device called a Newton meter. Be careful, because the SI unit for torque, TORQUE, so turning force, so moment, but like for rotational, is also Newton meter. So the SI unit for torque is also Newton meter, so force multiplied by distance. So moment with the rotational, it's more focused on rotating. Compared to moment can also be used for bending. Anyways, you can measure friction and weight and tension and applications of push force and other applications of push forces and also pull forces. And actually, in theory, if you're careful on small scales, you could measure water resistance or air resistance. So basically you can measure drag, which is pretty neat, right? That's pretty neat. Coolio, cool stuff. Cool, like a cryo pun, Unbalanced forces indicate a presence of a resultant force. Makes sense? Yep. If weight is bigger than drag, then the force will accelerate downwards, as the resultant force is basically downwards. The opposite can also be true. If weight is smaller than drag, then the object can accelerate downwards, as the resultant force is downwards. The opposite can also be true. If weight is bigger than drag, then the object will accelerate downwards, as the resultant force is downwards. The opposite can also be true. If a weight is smaller than drag, then the object can accelerate upwards, as the resultant force is upwards. When the velocity is 0, then it is stationary. In free fall, stuff accelerates, even as it is falling. Not despite of it, but even as it is falling. Well, actually, despite is the same as even. It doesn't make any sense, but it's okay. In free fall, stuff accelerates as it's falling. I don't need an even. Stuff accelerates as it's falling. Not despite. I don't need a not despite of it, do I? What is my brain doing? Okay. As it's falling, which means even without, that's where the even comes from. Even without giving stuff another nudge, stuff can fall to the ground rather than getting stuck in midair. I mean, imagine just levitating there like some sort of magical makeshift device. Levitation. Abracadabra. That would be interesting, right? It's giving like Cheshire Cat vibes, honestly. Gravity grants the force to fall to a rest, to an end of resting upon the floor. So like the gravity of Macbeth's situation leads to his downfall in the grave. To the grave. Bleak, but true, Surprisingly accurate metaphor. Surprisingly accurate metaphor right there, The resultant force is the vector summation of forces acting on the object in question. The resultant force is a vector summation of forces acting on the object in question. Oh, I guess we're getting Subway for dinner. That's nice. Oh, I need to actually finish this quick then. Well, it's 4:40. 4:38 p.m. It's going to be a while, but interesting. Okay. See you next time at Physics in Necrotic World. This is your host, Rimona Christian, R out.